Let's say you're walking on the equator, and of course the Earth is spinning. Now, do you know when you're traveling in a circle, you're spinning in a circle, you're accelerating? Obviously, the Earth wouldn't be spinning that fast. But if you were on the equator and the Earth was spinning, would you feel it? Whoa! Let's take a look. So let's calculate how fast the Earth would be accelerating if it was spinning. So if something's moving in a circle and you want to know how fast it's accelerating, you use this formula. Acceleration equals velocity squared divided by the radius. So it's a little more simpler than I thought, and let's calculate it out. The Earth at the equator is spinning 1,037 miles per hour. The radius of the Earth is 3,959 miles. Using a big number calculator and using the formula I just showed you, I plugged in the numbers, and the Earth should be accelerating at 1.327 inches per second squared. Of course, you're not going to believe me, so let's Google it. And here we got the same answer. Now let's ask AI. If you were traveling in a circle at 1,037 miles per hour with the radius of the circle at 3,959 miles, how fast would you be accelerating in inches per second squared?
Conversion factors, miles underscore to underscore inches equals 5,280.
And we got the same number. Okay, we got our little accelerator machine, got a big long arm for leverage, and then we're gonna use it to accelerate something or somebody. This is the accelerometer part of our machine. So we have marks 1 through 5 seconds, so we can use those to match our calculated speed of the Earth. The distance per second is not linear because the calculation is squared. So you can see here at 1 inch, obviously we're at 1.33 inches, and then at 3 seconds we're at 5.9 inches, and at 5 seconds we're at 16.6 inches. So you can see it changes dramatically. In order to keep a constant acceleration, you're standing on the Earth backwards. Here on the equator, we're going to accelerate the same as the Earth would accelerate if it was spinning. So this is going to be a 5-second deal. Ready? I'm not going to tell you when I'm ready. We're just going to go. Did you feel it?
Yes.
The whole time?
The entire time.
That's pretty cool. Let's see how we did on timing. All right, so right there is 98, pretty close. Right there, we should be around 3. We're 20 off, that's pretty close. Right here, about 20 off again, 22 off, pretty close, real close. And over here 40. So we're just a hair fast, and you can feel it. Not looking too good for the globe. Let's try it in a chair. Do it in a chair. Okay? Did you feel it the whole time?
Yes.
So yeah, you definitely can feel it in chair, standing, don't matter.
But I will say I felt it a little less in the chair.
That makes sense because you're top heavy when you're standing. Let's check the numbers. Okay, let's look at our time here. Alright, so we take off. Right there, we're like 105. We're a little slow. Right here, we're that's almost right on. One little bit slow, 306. We're slow there, like a quarter of a second, and then or like a half second slow there. So we're a little bit slow, and I can understand at takeoff you might feel a little bit, but she feels it through the whole way. So it's not looking too good for the globe. According to our results, it doesn't look good for the globe. Now we tried it with another person, and we got the same results. Now, remember when you're traveling in a circle, you're accelerating. So you can't just say, oh, I don't feel it because of gravity. It doesn't work that way. Okay, let's borrow a dog and try it. He's like, whoa. he can feel it the whole time. Now the ride's over. He's like, what was that? Okay, I'm gonna try to do it half speed this time. He's like, whoa. Yeah, then he sits down. He's like, yeah, I better sit down. Okay, let's take a look. All right, so as soon as you take off, you can feel it. Okay, right here we should be at 1 second. We're at 2 seconds. Oh, almost at 1.7, almost 2 seconds. And then like he's still feeling it. And he's like, whoa, and right here we should be at about 2 seconds. We're at 3. And then right here is like, I think I'll just sit down and enjoy the ride. Right here we're at it's supposed to be 3 seconds. We're at almost 5. And he's looking down. Oh, I can still feel this. Here we should be at 4. We're at 7. So even at almost half speed, he can still feel it. He's like, whoa. Yeah. Even at half speed, it's not looking too good. Okay, I'm gonna try to move it as slow as I can. Tell me if you feel it.
Okay.
Feel that?
Yes.
You feel that?
Yes.
I can't move it slow enough. You can't feel it. You feel that?
Yeah.
Like this, how about this? You felt that? That's fun. Wow, it's amazing how the human body can feel the slightest movement. Okay, now let's do the drop test. Let's check it out in slow motion. All right, so here we are in slow motion. We're going to drop it. And notice how it comes away from the level. Makes total sense because it's not accelerating anymore. And now it's moving away from the level. Makes total sense. Let's do it again. Same experiment again. And you can see it moves away again. This time the sled was a little quicker, so it moved away a little farther. Makes sense. And of course, if the sled's not moving and you drop it, it's going to follow the level straight down. Yay! So you should be able to go to the equator, set up a level, and if the earth was spinning and you drop it, it should move away from the level. But I guarantee you that's not going to happen. Which brings me to another point. I can understand the theory of gravity holding the air to the earth. But the earth is spinning, that means it's accelerating, like I showed you. If it's accelerating, wouldn't the air fall behind like the ball and create a wind speed to the west? In 1 minute, you would have accelerated 200 feet. I couldn't find a scientific explanation for this, except for Coriolis. But Coriolis doesn't explain why the air is following in unison with the earth. Well, to wrap it up, according to our results, it looks like if the earth was spinning, you would feel the earth move.